Okay, so let's finish up the two basic rules of probability. So let's talk about the AND rule. It's known as the multiplication rule. So if A and B are two events defined on a sample space, the probability of A and B equals the probability of B multiplied by the probability of A given B. So remember, this rule can also be written as the probability of A given B equals the probability of A and B over the probability of B. So basically what happened is this formula right here is the same as this. We just put it in a different format. So if A and B are independent, then the probability of A given B equals the probability of A. Then the probability of A and B equals the probability of A given B times the probability of B becomes the probability of A and B equals the probability of A times the probability of B. So the addition rule or the OR rule is if A and B are defined on a sample space, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. If an A and B are mutually exclusive, then the probability of A and B equals 0. So if you put in 0 for the probability of A and B, then probability of A or B becomes the probability of A plus the probability of B. If these rules are kind of confusing, don't worry, we're going to do some examples. So here's an example. Felicity attends a college, and the probability that Felicity enrolls in a math class is 0.2. The probability that she enrolls in a speech class is 0.65. The probability that she enrolls in a math class, given that she enrolled in a speech class, is 0.25. So what we're going to do is we're going to answer the following questions. We're going to let M equal a math class, S equal the speech class, and M given S equals math given speech. So the first thing we want to do is find the probability that Felicity enrolls in a math or in speech. The second one is we want to find the probability that Felicity enrolls in a math or a speech class. Part C wants to know, are M and S independent? And D is, are M and S mutually exclusive? Okay. And I put the notation under each of these so we can work them out one by one so you know where I'm getting the formulas. All right. So let the math class equal 0.2, the speech class equal 0.65, and let M given S equal 0.25. What is the probability that Felicity enrolls in a math and speech class? So that is an and. So I'm going to do the probability of M and S. So it's going to be 0.25, because that's the probability of a math given a speech class, times 0.65. So that equals 0.1625. And that was only used in the formulas we looked at before and the numbers given to me. So what's the probability that Felicity enrolls in a math or a speech class? All right, so there's a little bit of overlap, so let's look at it. So I'm going to look at the probability of math or speech, so equals the probability of math, 0.2, plus the probability of speech, 0.65, minus the probability of math and speech. And I solved that in the problem A, if you see that. So I've got to subtract for that because I have to get rid of the overlap. So when I do that, my answer is 0.6875. So the next one says, are M and S independent? Is the probability of M given S equal to the probability of M? So I know that the probability of M given S is 0.25, and I know that doesn't equal 0.2, so they are not independent. Are M and S mutually exclusive? That's what I'm asking is the probability of M and S equals 0? So here I go. So is 0.25 times 0.65 equal 0.1625? So that doesn't equal 0, so the answer is no. When you're working with these types of problems, write down, like I did up here, what everything means and put your letters out. And then from there, put your formulas and solve for the formulas. I know it's difficult, but if you can keep the stuff straight, it will make your life so much easier and make these problems easier to solve and easier for you to understand.